Hello class, this video will be an introduction to flow networks part 1. The learning intention of this video is for us to develop an understanding of a digraph and a flow network, and for us to learn how to find out what is the maximum flow of a network by inspection. Let's quickly talk about what is a digraph. A directed graph, also referred to as a digraph for short, is a network where the edges have a direction associated with them, and this is represented by an arrow, as you can see in this example over here. Directed graphs are often used to represent situations in which things flow from a starting vertex, which we refer to as the source, to a finishing vertex, which we refer to as sinks via channels. So if you look at the example on the right hand side over here, the source is going to be vertex A and the sink is going to be vertex F. The source of a network is defined as the origin in which things flow through a network. So in this case over here, notice how everything is moving away or leading away from vertex A, whereas the sink is defined as the final destination in which things flow to the network. So in this case over here, notice how all the arrows end up at vertex F. Now that we know what a directed graph is, let me talk about what is a flow network. So a flow network is a directed graph that contains weights on it, as you can see down below, and these weights have a special name to it. So we refer to these weights as capacities in a flow network. And what the capacity represents is, it represents the maximum rate of flow in which stuff can actually move through that particular edge. Depending on the context of the problem, these capacities that are shown on the actual network diagram could actually represent the water flow in which it flows through the pipes. They could also represent the traffic, so the amount of cars that go through the streets per hour. Alternatively, these capacities could also represent the number of supplies made per day going through that particular route. As you can see, these flow networks can be used to model many real-world scenarios, and by analyzing these flow diagrams, we can therefore determine what is the maximum amount of stuff or the maximum amount of flow that can be transported from the source to the sink. An example of this is that I might be able to work out what is the maximum amount of supplies that I could make from the warehouse to the cyclone shelter. Let's now learn how to find the maximum flow of a network. The maximum flow of a network is defined as the maximum amount of flow that can be transported from the source to the sink. So if you look at the example down below, what I've got over here is I've got a series of pipes that are connected one after another of different sizes. So in this case over here, water flows through these pipes and into the bucket. Because each of these interconnecting pipes have different sizes, we can see that the amount of water that each pipe could therefore transport will be slightly different. So if you examine the very first pipe over here, let's say that water can flow through that pipe at 25 liters per minute. And because that this pipe over here is significantly larger, let's say 70 liters of water can pass through that particular pipe. This particular pipe over here is slightly smaller, so let's say only 55 liters can pass through that. And the last pipe is significantly smaller, so therefore that has the lowest capacity out of all of them. If you analyze this particular system over here, what do you think is going to be the rate in which water will fill up this bucket? If you answer this correctly, the bucket is going to be filled at 10 liters per minute. This is because this particular pipe over here is the smallest pipe in the system. And what it does is it restricts the amount of water that could therefore reach the sink, in this case being the bucket. So as described over here, the pipe or the edge with the lowest capacity acts as a bottleneck. And what that means is it just therefore restricts or limits the amount of flow that could therefore reach the sink. Let's now look at an example with a network. In this second example, we're trying to find out what is the maximum flow from A to E overall. So in this case over here, A is going to be our source and E is going to be our sink. If you analyze this particular flow network, we can see that there are two ways in which traffic can go from A to E. So one of the ways is by going through vertex A, B, C, and E. In the very first pathway, the maximum amount of cars that can go through this particular route is going to be 300 cars. Another way of going from A to E is by going through vertex D. So if you go through that particular pathway, the maximum amount of cars that could go through that road is going to be 150. So therefore, to find out what is the maximum traffic flow from A to E overall, it's going to be the sum of these two numbers. So therefore, if you add 300 and 150, the maximum amount of cars that can go through these particular routes is going to be 450 in total. Let's now look at a slightly more complex example. So in this example over here, there's another road that goes from D to C, and that has a capacity of 500. In this case, again, we're trying to find out what is the maximum traffic flow from A to E overall. So again, what I'm going to do is I'm going to essentially draw different routes in which I can go from A to E. So one of the ways that I said earlier on was going from A, B, C, E. And we said that the maximum amount of cars that can go through this road over here is going to be 300. The other way that we listed earlier on was going from A to D to E. And that had a maximum rate of 150 cars per hour. And because we added an extra road, another way that we can go from vertex A to vertex E is going through this particular route over here. So again, what I'll do is I'll list down all of the capacities. So in this case, from A to D, that's going to be 500. However, from D to C, 500 cars do not go through this road at all. The reason for this is because from the 500 cars that went from A to D, 150 of them went through D to E. As a result, 350 cars go from D to C, so that's the reason why I've listed 350 over here. So therefore, the 350 cars that go through that particular pathway can therefore go through C to E, which is why I've listed 350 here. After I've done that, I can clearly see that the maximum rate going through this particular pathway is going to be 350. And to therefore answer the question, what is the maximum flow from A to E overall? It's just going to be the sum of these three values. So therefore, 300 plus 150 plus 350 is going to be equal to 800 cars per hour that can flow from A to E. I'd like you to now have a go answering a few questions. So find out what is the maximum flow of water that goes from the reservoir R to town E. So in this particular example over here, we can see that water can flow from the reservoir to town E in three different ways. One of the ways is listed down below, and we can see that by going through this particular pathway over here, the maximum flow is going to be 200 because that's going to restrict the amount of water. Another way for the water to reach town E is by going through this particular pathway over here. And similarly, in this particular pathway, we can see that the maximum flow is going to be restricted to 200 liters per hour. And finally, another way for the water to reach town E is by going through this particular route over here. And that particular route has a maximum flow of 300 liters. So therefore, the maximum flow that could reach town E is going to be the sum of these values, which is therefore going to be equal to 700 liters per hour. By now, you should be confident at finding out what is the maximum flow by inspection of a given network. However, I do want to let you guys know that finding the maximum flow by inspection will be very difficult when you've got a network that contains many vertices as well as edges. An example of a complex network is shown below. So as you can see, it's going to be very time consuming to find out what is the maximum flow by inspection using this method. So in the next video, I want to show you a more efficient method of finding out what is the maximum flow by finding out what is the minimum cut in the flow network. And all the textbook questions will ask you to use this particular method to find out what is the maximum flow. This is the end of the introduction video to flow networks. Thank you for watching this video, and I'll see you guys again in the next video. Bye.